Hello students, welcome to Swapna physics classes, and in this lecture I am going to explain you one more important short answer question for your TS IPE second year physics examination, and the question is derive an expression for the intensity of the electric field at a point on the axial line of an electric dipole. We have to find out the electric field on the axial line of the electric dipole. What is an electric dipole? An electric dipole is a pair of equal and opposite charges. That means both the charges are equal in magnitude but are of opposite charges. That means one of the charge is a negative charge and the other charge is a positive charge, and both these charges are separated by a distance of 2a. Both these charges are separated by a distance of 2a, and we have to find out the electric field on the axial line of this electric dipole. What is the axial line? The line which joins the negative charge, the center of the dipole, and the positive charge is an axial line for this electric dipole. And I am just extending this axial line, and at point P I am placing a positive charge. You need positive charge. We have to find out the electric field at this point P, and this point P is on the axial line of this electric dipole. Okay, and we have two different electric fields at this point P. One is due to negative charge and the other electric field is due to positive charge. We have two different electric fields. As this charge is a negative charge and this is a positive charge, the force between these two charges is an attractive force. Therefore, the force direction will be this one. And both these charges, this is a positive charge and this is also a positive charge. Both these charges are like charges. Therefore, there will be a repulsive force between these two charges. And I am placing this unit positive charge at a distance of r from the center of the dipole. From the center of the dipole, the distance of this unit positive charge is r. And what is the electric field? Electric field is equal to F by Q. This Q is a test charge. This Q is a test charge. Here test charge is a unit positive charge. Okay. And coming to the electric field due to positive charge and the electric field due to negative charge. The electric field due to positive charge is 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught into Q into unit positive charge by the distance between these charges. What is the distance between the positive charge and this unit positive charge? The distance between these two charges is, I am taking here, we have the two charges, positive charge and unit positive charge, and this is the center of the dipole, and the distance between center of the dipole and this unit positive charge is r, and the distance between the center of the dipole and this positive charge is a. Therefore, this distance will be equal to r minus a. Okay, therefore you just substitute here r minus a whole square. Okay, and what is the electric field due to negative charge? It will be equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught into Q into unit positive charge by what is the distance between this negative charge and the unit positive charge? What is the distance between the negative charge and the unit positive charge? Let's see. See, this distance is a and this distance is r. Therefore, the total distance will be r plus a. The total distance will be r plus a. R plus a whole square by unit positive charge. Here also we have divided by unit positive charge. Why? Because the electric field is equal to F by unit positive charge, right? Therefore, the total electric field is equal to sum of the electric field due to positive charge and the electric field due to negative charge. But if you observe carefully, both the forces are opposite to each other. Therefore, here we have a minus sign. Here we have a minus sign. The force due to negative charge is on left side and the force due to positive charge is on right side. Therefore, here For negative charge, I am taking the minus sign, and for positive charge, I am taking the plus sign. This is the direction of the electric field due to positive charge. This is the direction of the electric field due to negative charge. Therefore, I am taking minus sign here. I am taking plus sign here. Right side lo unto plus sign this column, left side lo unto minus sign this column. Now, therefore, I am substituting these values in this equation. We will have the total electric field as 1 by 4 pi epsilon naught. I am taking this Q and 1 by 4 pi epsilon naught common. Q and 1 by 4 pi epsilon naught is common. Q by 4 pi epsilon naught into 1 by r minus a whole square, 1 by r minus a whole square minus 1 by r plus a, 1 by r plus a whole square. You just take the common and solve this problem. Therefore, the total electric field is equal to, I am taking LCM here, r plus a whole square minus r minus a whole square by r plus a whole square into r minus a whole square. This will be equal to, you just apply the formula a plus b whole square. Therefore, we have r square plus a square plus 2ar minus, here we have minus sign, minus r square minus a square, minus into minus plus 2ar by, see this is a plus b whole square into a minus b whole square. A plus b whole square into a minus b whole square is a square minus b square whole square. Here therefore we have r square minus a square whole square. Therefore the total electric field will be equal to, here minus r square plus r square and minus a square plus a square get cancelled. Therefore we left with plus 4ar by r square minus a square whole square. This is the total electric field. As the distance between this unit positive charge and the center of the dipole r is very much greater than the distance between these charges to the center. Okay, we can neglect a. Therefore we have 4ar by r square whole square. This will be equal to 4ar by r power 4. R 1r get cancelled. Therefore the total electric field is equal to Q by 4 pi epsilon naught into 4a by r cube. If you observe carefully, what is the electric dipole moment? It is equal to 2a into q. If you observe carefully, here we have 2 into 2aq. 2 to the 4 into aq by 4 pi epsilon naught into r cube. Therefore, the total electric field is equal to, we just substitute the electric dipole momentum in this equation. We have 2 into p by 4 pi epsilon naught r cube. In vector form, the total electric field is equal to 2p by 4 pi epsilon naught r cube into p cap. This is the electric field on the axial line of the electric dipole. Okay, here I will end our lecture, and whoever didn't subscribe to my channel, please click on the subscribe button and share with maximum number of people, and also click on the like button. Okay, bye.